Great. Well, it's already 12:02, so we're going to go ahead and get started today. So hello, everyone. We're so excited to host you today and welcome you to the fifth installment of the Agroforestry series, co-hosted by the Delta Institute, Liberty Prairie Foundation, and the Savanna Institute with support from US EPA. As folks are trickling in and getting settled, please introduce yourself in the chat and where you're zooming from, and a few housekeeping items. Everyone's going to remain muted during the webinar for better sound quality, but please feel free to put your questions, your comments in the chat, and then we'll address them during the Q&A session with our presenters at the end. This session is going to be recorded and posted on YouTube within the next couple of weeks, so you can always come back and share with folks that weren't able to join us today. As we begin today's session on soil health and how agroforestry and trees can support healthy soils on our farmlands here in the Midwest and beyond, I'd like to invite our partners to introduce themselves and share a little bit about their work and why we're all working together to support agroforestry adoption. So Nathan, would you go ahead and kick us off for Liberty Prairie Foundation?
Sure. Thanks so much, Katie. So the Liberty Prairie Foundation is a nonprofit that develops and demonstrates different ways for people and nature to thrive together. We're located in Grays Lake in the Prairie Crossing Conservation Community, where we own and manage a 94-acre farm, all of which is nested within the 5,800-acre Liberty Prairie Reserve. We care about agriculture because that's the main focus of our work, because that's where people and nature impact each other so profoundly. We care about, and we're so interested in agroforestry because it offers perennial, promising ways for people to get food from nature.
Thank you so much, Nathan. Now I'm going to hand it off to Josh with the Delta Institute.
Hi, Katie. Thank you. Josh Zuckerman with Delta Institute. Delta helps Midwestern communities solve complex environmental problems. This is a really exciting webinar for us on soil health, because we have a great deal of work that we're currently doing with soil health throughout the Midwest, where Delta is looking at soil health and land valuation. That if farmer A has healthier soil than farmer B, in theory, we would think that their land should be worth more money based off of ecosystem services and all things that soil health can provide. So it's very interesting. Happy to be here today and looking forward to the presentation. Thanks, Katie.
Thanks so much, Josh, for sharing that exciting work that Delta Institute is engaged in. And I'm Katie. I'm the Director of Demonstration Farms at the Savanna Institute, and we're a nonprofit organization based in Illinois and Wisconsin that's really working to lay the groundwork for widespread agroforestry adoption here in the Midwest. And we do that through a variety of ways, mostly focused on research and education and outreach. But a couple of programs I want to highlight is our technical service program for farmers and landowners that helps get trees on the landscape, our tree crop breeding program, and market and commercialization research, as well as our network of research and demonstration farms, where you can come see what we're going to talk about in this webinar and this whole series in practice. And we're so excited to be partnering with Liberty Prairie Foundation and Delta Institute on this series and agroforestry adoption. And before we get into the main event, we have a couple polls so that we can get to know each other a little bit better. And Lucas just launched the first one, which is a really simple one with, who are you? There's probably multiple answers to these questions, but choose one of how you spend the majority of your time. Ooh, I love watching the polls change a little bit as folks submit their answers. Okay, and we have about almost 90% participation. So let's go ahead and close that poll. And it looks like we have a pretty even split between farmers and landholders, agency and government employees, and nonprofit employees. So we're excited to have you in the room to work with the folks that are on the ground and might be implementing these practices. And I'll share those results for folks. Okay, and let's move on to our next poll. What would you like to get out of the presentation today, and what might you take with you out of this space? Okay, it looks like the majority of folks have responded to the poll, so I'm going to go ahead and end that and share the results. Another pretty good split, but a lot of folks are just curious about soil health and agroforestry, and about 30% of folks are interested in implementing agroforestry on their land. Great. I hope that we can provide some really great options for you all as you move out of today's webinar. So to center us on the topic of this webinar series, I'd like to remind folks why we're here and why we're so focused on agroforestry. So this agricultural system, which is an integrated approach to farming with trees and livestock, is one with many different yields and benefits and invitations to combine production and conservation and community building over time. And while there are hundreds, if not thousands of ways farmers have utilized these systems over time and around the world, here in the US, we're often focused on the 5 supported practices by the USDA. And the first one of that is alley cropping, which is the cultivation of crops between rows of trees, often spaced so that there can be annual production and sometimes perennial production in between those tree systems. Silvopasture, which is the intentional integration of trees, pasture, and livestock managed as a single system. There are kind of 2 ways to do this: silvopasture by addition, where we're planting trees in pasture, and silvopasture by extraction, where we're taking wooded areas and increasing tree health and establishing pasture underneath. A reminder that these are intensive and intensively planned and integrated, so it's not just letting animals loose into a wooded area, it's planned for the health of animals and the ecosystem in mind. The third are productive riparian buffers, so strips of permanent vegetation alongside streams, lakes, or wetlands. And in agroforestry, we add woody species and productive woody species to those. The fourth one are windbreaks, which used to be very common across farmland where I am in central Illinois, but they're strips of trees and shrubs to enhance crop and livestock production, oftentimes stopping wind, drift, snow, and other things to boost yield. And the last one is forest farming, which is the cultivation of specialty crops under forest canopies. Things like mushrooms or medicinals like ginseng, which can be really productive for folks in mostly wooded areas. And without further ado, I'm excited to introduce our 2 speakers for today's webinar, Randy Jackson and Erik Hagan. Randy is going to walk us through the principles of soil health and outline how his research and the work of others provides valuable data on how agriculture can be a solution to many of the problems we face. And Erik Hagan is going to situate this information in the field and walk us through how soil health principles are foundational to his work as a farmer and an agroforestry practitioner. And so thank you both for being here. And Randy, I'm going to let you take it away.
Great. Thank you so much, Katie. And thank you to this wonderful consortium for the invitation and opportunity to talk about some of the work that we've been doing under the general framework of this project we call Grassland 2.0. And I'm going to talk about some data today that come from a project that we call the Wisconsin Integrated Cropping Systems Trial, which is a long-term side-by-side randomized replicated cropping systems trial. And we kind of think of that WIXT experiment as a part of this bigger Grassland 2.0 effort. So we don't have trees at WIXT, and I don't have data specific to agroforestry systems or savannas, but I do think that the data that we've been collecting from this long-term experiment have a lot to inform all manner of agricultural management, but in particular can really be helpful in the agroforestry realm. The notion of Grassland 2.0 is that we have to, one way or the other, eventually have an agricultural system that restores a significant amount of the structure and function of the original grassland biome of the upper Midwest. And so much of our work is trying to think about ways we can move towards this economically, what the ecological trade-offs are, and then engaging in a lot of social science to understand what the real impediments are to moving towards systems like this. The Grassland 2.0 project is based at Wisconsin, at the University of Wisconsin-Madison. We have a lot of partners that are all noted here on this decal screen. Savanna Institute is one of the key partners, the Pasture Project, the Land Institute, et cetera. And it's just been a really fun and exciting project. It's a 5-year grant from USDA. We're in year 4 of that grant and already starting to figure out ways to keep the movement alive, to help build the movement. And it's really important for us to note that it's not our movement, it's not a Grassland 2.0 movement, but we're trying to sort of lift up voices and lift up the work of so many great organizations and individuals who are moving in this direction. The spirit of the Grassland 2.0 project emerges from the words of Leopold, and I like to try and distill them here into my little identity, which is that when we take care of the land, we take care of ourselves. That when we separate these things, when we think of the land separately, or when we think of nature separately from humans, that we do so at our peril. And I think you could argue that's been the tack we've been on for a long time. One of the saddest things I've heard is a colleague of mine, he wrote this somewhere, that isn't it sad that Leopold's main legacy has been a literary legacy and not an actual agricultural legacy. And so a lot of the Grassland 2.0 work is an effort to try and take Leopold's words and help transform the landscape and build that in the spirit of the land ethic that Leopold left us with. So let me jump to my summary slide, and then I'll try and back it up with some data. And the takeaways, I have 3 main takeaways for the day. The first is that healthy soil is aggrading. Healthy soil is growing, not shrinking, not being lost, not being eroded. You might say it's regenerating. And of course, we all know about the term regenerative and regenerative agriculture. And so I want to kind of explore that just very briefly. I want to say that soil accumulation only happens when all 5 soil health principles, which I'll run through here in a minute, are fully applied, and try and back this up with some data that we've been collecting. And then also, and then finally, I want to come back to the structure and function business and just talk about the importance of restoring ecosystem structure and managing that structure well to get the function that we need, the functions that underpin important ecosystem services, whether that's helping stabilize the climate with carbon accumulation, or holding on to nutrients to keep water clean, or supporting and enhancing biodiversity, et cetera. So let's talk about healthy soil growing and not shrinking. This is taken from the NRCS's website, and I copied and pasted a couple of things, so it's kind of awkward here, but really is just getting at what is soil health. And the most often seen sort of definition of soil health talks about it as continuing the capacity of soil to function as a vital living ecosystem that sustains things that we need, plants, animals, humans, sustains clean air, clean water, et cetera. And so those are sort of the outcomes that come out of soil health, but that's not soil health, it's, in and of itself. And so if you work further through this NRCS website, you get to this paragraph here, which unfortunately leans in at the beginning here on the idea that we have to feed the world, but let's move past that for a minute and talk about the fact that mainly it's talking about the fact that when you improve soil health, that you're building soil organic matter and improving microbial activity, that you're sequestering carbon, which of course is about half of organic matter. And so I'm just really trying to highlight that when we talk about soil health, organic matter is kind of the great integrator and sort of the main thing that we can look at as pointing us in the right direction on healthy soil. Here's a little cartoon that comes out of the Soils Bible by Brady and Weil, The Nature and Property of Soils, which talks about or depicts, soil carbon, soil organic matter. Again, about half of soil organic matter is carbon. Prior to European colonization and cultivation. And you can see here what's depicted is that as soon as we took the plow to the prairie, we had this precipitous loss over a couple of 2 or 3 decades of soil organic matter, especially these so-called active fractions, which are just the plant residues that have accumulated in the soil. The active organic matter, that's a little more decomposed carbon. The slow organic matter, which is an even more decomposed part of the organic matter, and then what we call the passive organic matter fraction. And these are not real categories. This is a gradient from less decomposed to more decomposed. But the point of this is just that initial soil disturbance and the continued soil disturbance blew off massive amounts of carbon from the soil that I like to think of as fossil carbon. Technically, it's probably not fossil carbon, but it's carbon that had accumulated over thousands and thousands of years, generally under prairies in our part of the world, but also under savannas and to some degree woodlands. And it's hard not to look at this plot and say, any kind of agriculture that's continuing to mine this so-called fossil carbon, the soil carbon, should be considered extractive. And I don't mean that to like cast aspersions or say that people who are doing this are bad people. It just is what it is. We're mining what's there. And so much of today's conversation is about trying to move to systems that actually regenerate the soil and regenerate carbon and organic matter. And so a big question is, what are those systems, and do those systems exist? Can we do that in an agricultural context? Is that possible? And what I'm going to move to here in a minute is that it may be possible, but it's pretty dicey. It's not a fait accompli, and the management is super important, and the species we choose are super important, and it's all in the context of a changing climate, which is the real wild card. This graph kind of implies or assumes that there's a stable climate, and we know that there isn't. So this is some of just to get you sort of on board with some of the magnitude of the issues that we face. So suffice it to say, anything that we do depicted over here on the left that really disturbs the soil, that washes away the soil, that relies heavily on actual fossil fuels, whether that's nitrogen application or diesel fuel to drive heavy machinery, et cetera, are very, very unlikely. And I would say it's almost impossible to have actual regenerative agriculture in this context. Truly regenerative agriculture, as I say, actually lends to building soil organic matter. And so here's, maybe our best bet at doing that. Maybe our only hope of doing that is by getting perennial grassland restored to the landscape, managing it well with livestock, managing the livestock so that they're holding on to nutrients as much as possible. No ecosystem is completely tight and closed. And the more we disturb it, the more likely it is to leak. And so we have to really manage those things very carefully. And there's a lot of work to be done there, a lot of science to be done to explore how we do that. So what emerges then from, our sort of analysis of what helps protect the soil, helps take care of the soil, are these 5 really, really laudable principles. Minimizing the disturbance of the soil, keeping the soil covered always with some sort of green or perennializing the agricultural system, if you will, maximizing the diversity of the system, whether that's the plants, the animals, or the microbes, maintaining living roots in the soil, and then the 5th principle of integrating livestock. And so this has been a wildly successful campaign to push these ideas, and there is this sort of notion that you can kind of pick and choose your recipe here. And I guess what I want to impress upon you today is that I don't think we can just pick and choose. I think we have to have all 5 of these principles in place and fully implemented, if you will. In other words, not just a little bit of diversity and not just a little bit of integrating livestock, et cetera. Like, it's got to be restoring the structure and function of the prairie biome. And so that's the takeaway here, that soil accumulation only happens when all 5 of these soil health principles are fully applied. So let me share with you some data that sort of supports this rather aggressive take on soil health. This is work from super grad student Abby Augarten, who's now working in the extension space at the University of Vermont. We were sad to lose her from Wisconsin, but she did this fantastic work where she collected data with the help of some other grad students in Matt Ruark's lab here on campus. Over 746 plots, and you can see how they were distributed across these 4 different categories: pastures, forage, which is generally corn and three years of alfalfa, annual cropping systems where manure is being applied, 180 of those plots, and then annual cropping systems where manure isn't being applied. And what's important to note here is that within each of these 4 categories, there's a tremendous range of variation in the way those systems are being managed. So for instance, the number 4 down here, the annual system, while they're not receiving manure, some of these may be no-till, some of these maybe have cover crops incorporated, some of them none of that. So there's a tremendous range of practices within these categories. Likewise, these pastures, some of them may have been continuously grazed by livestock and not managed particularly well. Some of them managed quite well with well-managed grazing. So lots and lots of variation within these. And so I've tried to take the soil health badges and sort of apply them to these 4 categories. And you can see here that the pastures, generally speaking, employ all 5 of the soil health practices. The alfalfa rotations, they employ all 5, but not fully. You know, they minimize soil disturbance, but they don't eliminate it the way pastures do. They keep the soil covered, except when when we're rotating into corn. They maximize diversity by having 2 species in a rotation. You know, that's not really what we mean by diversity, et cetera. They integrate livestock by bringing manure back into the system, but generally in 1 big pulse or 2 big pulses a year. So we're not really fully integrating the livestock into the system, and so I've made these badges smaller. The annual system with manure doesn't get the badges for minimizing soil disturbance because they get planted every year, so the soil gets disturbed every year. They don't keep living roots in the ground, et cetera. You get the picture here that the badges get applied according to these categories. So the big takeaway from Abby's work, when she looked at soil organic matter, you know, the main metric of healthy soil, you can see here that the pastures were set apart with a full percentage point more organic matter than all of the other systems. And what's really amazing is that none of the other systems were different from each other. And so this is where I come with my analysis that, you know, without all 5 fully implemented, we're probably not moving the needle on soil health, in as much as soil organic matter is sort of our main metric of soil health. I'm going to skip through this, but we do see these so-called sensitive indicators of soil health, like HOC and mineralizable carbon, which are really metrics of like how much carbon is coming into the system. We do see those responding to these different soil health interventions, if you will. And so it's really interesting that what we think is a sensitive indicator doesn't seem to be mapping to the longer term total organic matter that's emerging from these systems. Let me talk real quickly about work that has emerged from this Wisconsin Integrated Cropping Systems trial. I don't have time to walk through all of the systems, but there are 3 cash grain systems and 3 dairy forage systems. On one end is continuous corn, on the other is well-managed rotational grazing. And we were fortunate enough that Josh Posner and friends collected deep cores in 1989, and then Greg Sanford, his grad student, came back in 2009. And when we look at the actual change in soil organic carbon across these 6 cropping systems, you don't have to stare at this very hard to see that all of those annual cropping systems, even the ones with forages, we're losing a significant amount of carbon over a 20-year period. the pastures were holding on to the carbon they had. They weren't significantly different from zero. And what's fascinating is that they did gain significantly in the surface horizon, say down to 30 centimeters, but lost from 30 to 90 centimeters carbon that offset the gains in the surface. And this is one of the big problems with the literature around soil organic carbon, is that most of the work is focused on the surface horizons. And if you don't take into account what's happening at depth, you're probably seriously overestimating this capacity of a system to accumulate carbon. I'm going to skip this in the interest of time and get to this bit about the importance of restoring the structure of the system to get the function that we want. And so part of the WIC system is that we have these warm season prairie grasses planted as a monoculture, the switchgrass, sort of a minimal diversity prairie, but it's 6 grass species. And then high diversity prairie, which was over 25 mix of grasses and forbs planted. And Claire Dietz, grad student extraordinaire, is currently working up these data and trying to get them out to press. These grassland systems were managed in various ways. Some were burned, grazed, fertilized, bioenergy harvest, etc. Busy slide here, but the takeaway message is this, that a little bit of diversity is important. You can see the switchgrass systems, generally speaking, losing carbon. The grazed and burned wasn't significantly different from zero. The low diversity grassland prairie, no matter how it was managed, significantly gaining carbon and gaining a lot of carbon, 200 grams carbon per meter squared per year. That's a lot of carbon to be gained. And you can see the errors are very tight. Relatively uniform homogeneous stands of prairie grasses that are quite productive. On the other hand, the diverse prairie, which had a lot more diversity in the structure of the vegetation and whatnot, a lot more variation in carbon, and that variation caused some of the systems not to significantly change from zero, even though there was this tremendous variation. The one thing that helped those systems accumulate carbon was burning them frequently, and we know that that promotes the grasses over the forbs, and so that management was really important for helping that system accumulate carbon. Last data slide, and I'm going to wrap up. This is the same data set, but broken down by depth. And really the thing I want you to see here is that when systems actually accumulated carbon, they accumulated carbon at depth all the way down to 90 centimeters. So here's the switchgrass systems. You can see that they were kind of trying to gain carbon in the surface horizons, but for whatever reason, we're losing carbon at depth. The diverse prairies, they were gaining carbon even down to 90 centimeters, and the burned high diversity prairie gaining carbon down to 90 centimeters. Just want to drive home the importance of structure, and maybe this is a nice handoff thinking about agroforestry and the role of trees in an agricultural context, in a grassland context, in helping get deeper roots down to deeper parts of the soil to put more carbon down there to offset what might be happening in the absence of root production in deeper soils. So here's a recapitulation of my takeaway messages: that healthy soil is growing, not shrinking. It only happens when we get all 5 soil health principles fully applied, and we have to restore the structure and manage that structure well to get the functions that we need so desperately out of our agricultural systems, so that our agricultural systems can actually be part of the solution and not part of the problem. Thank you so much, and I'm going to turn it over to Erik.
Thanks so much, Randy. We're going to hand it off to Erik Hagan. And if you have questions that came up during Randy's presentation, please throw them in the Q&A in the chat, and we'll address them at the end.
Yeah, excellent. Thank you so much, Randy. That's such amazing information, and really exciting to think about and see that data coming out. And I'm really excited to share with you all what we're doing on the Spring Green campus. When I was asked to present with Randy, I was obviously really excited. Randy's a powerhouse in the community. So it's a really honor to kind of chat side by side with him and the work that they're doing with Grasslands 2.0. It's pretty admirable and inspirational work. But I was also asked to kind of share a bit from a farmer perspective, or what we're doing specifically within agroforestry, and kind of through the lens of the Spring Green campus. So as Katie mentioned, my name is Erik Hagan. I'm the farm director for the Spring Green campus. So most of my work within Savanna Institute is developing the farm operations at the Spring Green campus, which I'll talk a little bit about in a moment, what that is and what that means. So I'll go in a little bit about what agroforestry's role is in soil health, and how it does that a little bit, not with as much data. Luckily, I see Nate Lawrence, who is our ecosystem service scientist, is on this call as well today. So hopefully when we get questions towards the end, he might be able to field some of those, because he is the one doing the soil health monitoring and measuring for our demonstration farms and our research program. So yeah, kind of getting to what Randy was saying, our work is really kind of looking at moving the needle, actually moving the needle, and we really want to see progress on the ground in a large scale way, and get away from this notion that soil health can happen within a conventional or how we have been doing it, that there is enough information and evidence out there that status quo is not working. And one of the ways that we think about doing this is, just like Randy was saying, through perennialization, through the soil health metrics, but also just through perennialization and differentiating the system through diversity. So the way we focus on it is, like Katie mentioned, through agroforestry. We're looking at really creating a dynamic ecosystem, managing ecosystems from the canopy down to the soil, the below ground soil. And we do this with the lens on soil health, and priority for soil health, because we cannot get all of these wonderful functions in this slide that you see here that Katie shared earlier without soil health. It is the basis of the full system. And as kind of I'll describe a little bit about where we're at with the Spring Green campus and the work we're doing on the ground, I really want to just stress the fact that early succession processes is absolutely critical to that. Focusing on soil health day one, not thinking about planting trees and walking away and 20 years later, yay, it's working. Or planting pastures and not managing them properly, and yay, it's working. It is not the case. It is day one intensive and intentional management to actually move that needle and get these systems actually doing what they're purported to do. And also within agroforestry, a big component of it is it's a long range strategy. It's incorporating trees that when they start, they are either seedlings or a foot tall, 2 feet tall. They're not doing a whole lot of interactions with the soil horizons in the early days, but it's setting up an intentional system, and one that kind of succeeds or evolves over time into alternate management systems. And in planting trees in farm fields, we get this all the time. Why are you planting trees in farm fields? It's kind of crazy. We finally remove them so we can manage properly. But it really, in a way, focuses you on being intentional about your management. It focuses you on doing good design, putting trees in the right place at the right time for the right reason. Understanding how runoff is happening, or understanding how your soil carbon is being lost, or minimizing disturbances, or providing habitat, or whatever metric or benefit you're trying to go for. It really focuses you to be incredibly intensive and intentional about it. And then that kind of translates back into your management. So it's no longer just an assumed or perceived benefit you're getting out of the system, but you really need to see that benefit over time. So getting back to what Randy was chatting about with these badges. I love how he calls them badges. Kind of reminds me of pogs in a way. But these kind of 5 badges of soil health principles. And to me, what all of this is speaking to is about encouraging soil biology, getting back to farming the soil, farming the microorganisms in the soil. And this is what really all of these badges are maximizing. And this is something, the USDA released the Soil Food Web decades ago. And this is something that we don't often hear as much about from the USDA. We look at these badges and there's really nothing kind of explicit in there about encourage soil microbiology or inoculate soil biology, or but each one of these badges actually do lead into the development of soil biology. And there might be a whole slew of industry reasons for why this might be occurring, but I like to think about always focusing on the soil biology, and these are just practices or strategies to do that. And with agroforestry, we are really increasing the complexity of the system, right? And that's kind of a major badge of the soil health. It's maximizing diversity. You're adding in a whole other layer of diversity into the system. You're planting different species, sometimes multiple species. Could just like in Randy's example, one tree species or 25 different tree species within the field. And it gives you a lot of opportunities for increasing different livestock scenarios for like silvopasture, which Katie talked about earlier. The canopy protects the soil, keeps the soil covered from intensive rainfall, provides additional living roots deeper in the horizon or in different areas in the horizon. Also with different types of rhizosphere development, even in the soil horizon. So getting at that diversity piece. And immediately when you plant a tree, you're minimizing soil disturbance. You're putting something in place of a soil disturbance. You might do a soil disturbance at the start, which I'll show in a minute what we've done to do that. But after that, it's a permanent system and it's permanently in place. And what you get, just like in any ecosystem, that edge between grassland and the forest, that is the most diverse ecozone or part of the ecosystem. The most diversity kind of is in that edge, that differentiation between those spaces. And that's effectively what we create in an agroforestry system: constant and multiplied edges, endless amounts of edge spaces. So increasing that diversity and providing all of that opportunities for just tons and tons of soil biology and the microbiology, which interacts with the whole trophic level all the way up to what we eat and what our atmosphere is doing and how we're functioning as a grander global ecosystem. Agroforestry can really help lead and participate within that. So this is kind of a lot of ideology, right? This is, I'm kind of speaking without data here, and I wish I had more data to share in this presentation, but I kept it kind of simple with my 15 minutes I have. But the way trees really do that is by increasing a lot. I keep mentioning that diversity piece, but it increases a lot of diversity of the organic matter that's being moved throughout the system. In the aerial system, there's just a tremendous amount, especially in deciduous trees, a tremendous amount of leaf litter fall. There's a tremendous amount of exudates that come out of that leaf litter that causes all kinds of chemical interactions at the soil, which spurs an entirely different form of biology for all kinds of nutrient cycling differentiation between grasslands or annuals and tree species. And then you got all the below ground interactions, all the root exudates that are moving forward, searching for inorganic forms of or organic forms of nutrients and releasing them through root exudates or symbiotic relationships with fungal species and bacteria and the whole crazy rhizosphere that we're just barely starting to understand. And then how it moves water in the system is tremendously variable. Trees have an ability to provide hydraulic lift, which is an ability for the tree to actually re-release moisture in the upper horizons of the soil, which leads to less drought restrictions on herbaceous species that are in the understory, which constantly keeps living roots in the ground and living primary productivity happening on a continuous basis when there's reduced stressors around them in the environment. But then also especially in an agroforestry system where we are doing intensive pruning, we are doing intensive silvocultural management of trees, we're pruning a lot of the root tops. And that, just like in mowing or haying grasslands, when you prune those branches, those aerial parts, you get a similar sloughing off of the roots in the below ground. So you have this whole dynamic soil horizon variation of how the roots are interacting and how they're dying and consuming and translating nutrients and cycling nutrients and invigorating biology and converting biology. So a tree, especially with agroforestry, we're not saying plant a forest and get rid of the grasslands or get rid of the corn and plant a forest. We're saying do both. We're actually adding in this layer of complexity and trying to discover systems in ways that we can find that balance. There is no perfect system. As Randy said, there's no perfect closed loop system, but is there a way we can kind of teeter that balance even a little bit more, encouraging livestock to graze in here after a corn harvest under the shade of chestnut trees, and just getting more and more complexity in the system to help with that balance. So as kind of an example of this process, especially in the early succession process, I'll just run through kind of the Spring Green campus a little bit and kind of our year one transition, so to speak. So the Spring Green campus is Savanna Institute's home demonstration and research facility in Spring Green, Wisconsin. We have just under 800 acres on 4 farms on 2 sides of the Wisconsin River, and completely different soil types and soil structures and differentiating types of landscape contexts. And the purpose of these farms is developing these systems, researching, understanding, and the how-to and the outcomes of developing these systems. What are the soil organic carbon outcomes? What are the nutrient cycling outcomes? What are the yield outcomes? You know, looking at these tree cropping systems for their gaps and barriers for adoption, like tree crop breeding, you know, tree crop improvement program, or even tree crop availability through development of a tree crop nursery. We do a lot of work, which I'll explain quite a bit here today, is in piloting these systems. So actually doing the risk abatement by trialing how these systems work, and do they work, and can they actually be more effective than a corn or annual system, cost effectively, and on all the ecosystem services outcomes that we're looking for and talking a lot about. So the campus is a really dynamic living laboratory, and there's a tremendous amount of opportunity to engage and come visit us and learn from us and teach us and be part of this community. But for today, I'm going to talk specifically about North Farm. So this is the first property that we acquired back in end of 2019. No, sorry, end of 2020. It's 331 acres. When we purchased the property, it was in a corn alfalfa rotation, just basic silage corn and alfalfa. So complete harvest of all the aerial biomass extremely intensively on a 5 to 6 year rotation between the alfalfa and corn. So extremely intensive conventional management, a lot of manure application, which is helpful. But we received the property in a depleted shape, and I'll talk about the organic matter in a moment. We're actually here. So one of the first things that we did was we really kind of studied the soils. The soils here are highly erodible, sandy, loamy, sandy loams. They're extremely erodible, a lot of steep slopes, kind of hovering around that 12-degree gradient, and with a lot of cultivation history and a lot of compaction from all the forage wagons and the haying that has been occurring for the last 40 years. This property has not been grazed for the past 40 years, so it's just been manure application has been the interaction. It's pretty typical of a dairy cropping system in our area, the driftless community. So the next thing we focused on was kind of understanding the organic matter. Oh boy, I have 5 minutes. So I guess what I'm getting at with this is focusing on what the soil type is. What is your context? What is the landscape context? What is the topography? What are your watershed issues? In this example, on this farm, we have one complete watershed. The entire farm drains to one culvert that goes directly into the Wisconsin River. So this is a really unique opportunity for us to research an entire sub-basin watershed and our interactions and our influence on this watershed. But understanding the role of that is absolutely critical to understanding how to do soil health on your farm, because every farm is entirely different. No practice is the same, and no ideology is 100% accurate. The farmer is the one that has to be engaging on this process to ensure that their management is actually leading to the outcomes that we're trying to expect out of the system. And so really going through kind of a protracted design scenario, really understanding those scenarios and what to do and what your influence is going to be on that in order to get that intentional outcome. So this is what we did. We decided that we're going to do a hazelnut pilot farm and a chestnut silvopasture for year 1. This is not highly diverse at the moment, but again, year 1, we're talking the next 100 years of work here. So we started off with the development of a hazelnut alley crop, converting of crop ground straight into a hazelnut alley cropping system. So that's a 7-acre system of clonal hybrids of hazelnuts there. They're machine harvestable. And then we did 10 acres of a cold hardiness research project for chestnuts as a silvopasture. So grazing the between alleys, or researching even fencing opportunity to graze between alleys with cattle and sheep primarily. Year 1, as I mentioned, year 1, we took the farm on and it had about 1% organic matter. It was pretty consistent. We're on pure what they call blow sand or sugar sand in this area. There is a sand dune that actually blocks the major valley from getting to the Wisconsin River, why it necks down into one culvert and forms that one solid watershed. It's not a big valley flowing in with multiple entry points to the Wisconsin. It all focuses because there's a huge sand dune that blocks the whole valley. So it's tremendously sandy, very low organic matter, very low nutrient retention. So the first thing we did was took a full year to redevelop the site, just re-trigger something else, stop taking material off the site. So I went with a really heavy, complex cover cropping mix of sorghum sudan, sunflowers, cowpeas, and sun hemp. Mostly heavy lignified species and species that you can mow repeatedly over the course of a year for getting tremendous amount of biomass that just keeps getting put back on the surface of the farm here. And the importance about the lignification is we're planting trees into essentially an annual cropping system. So an annual cropping system is bacterially dominant, not 100% bacterial, but it's dominant in bacterial species in terms of the saprophytes and the breakdown and releasing of nutrients and the mobilization of nutrients. And we're looking for a more fungally dominant system. We want to move towards this system as our trees develop, because our focus is on succeeding to get these trees to the best possible place so we can have the most optimal outcomes. So going with a high lignified system, it could be a million and one ways to do this, but this was just an early, cheap, and easy way to get this started. And then the following year, we planted the hazelnut. So we started the hazelnut alley cropping. And as you can see here, there's actually 3 blocks. So this is a setup research trial with different spacings and different cultivars, but also different management techniques that I'll go into in a minute. By alley cropping, we talk about growing crops in between rows of perennial trees or shrubs. In this case, we did specialty crops. We're looking for a system that can be done at multiple scales. So we are doing some small grains, we're doing some grazing, we're doing some forage, we're also doing some specialty crops for different scales of people to adopt this system. In this case, this is carrots here. We got potatoes here. It's hard to tell, but this is a row of hazelnuts, rows of hazelnuts on both sides. And because soil health is our big focus, we're looking at the rotation of these, the rotation of grains with livestock, with cover crops, with annual crops, with perennials. So we kind of set up a kind of a staggered system. This is on actually a pretty steep slope here. It's actually about a 6% grade. So every other row is cropped and every other row is still cover cropped and still doing that same at year 1, just mowing down to get increased organic matter. Try to reinvigorate that biology, get as much happening on the surface and the subsurface as possible, just to try to move this system forward and see if we could see any outcomes. So again, a lot of cover cropping and a lot of diversity within that cover cropping. So doing some buckwheat, doing some sorghum, no-till drilling the sorghum into the buckwheat. When all of this winter kills in the winter, we no-till drill rye. So we have living roots extend through the winter as well and into early spring. So rye is one of the earliest things to come green in the spring and start growing right now under the snow. And really about diversitying that biomass. We're also looking at, again, going back to that lignification process. So even in the in-row, we're working on what does soil health look like in the in-row and really focusing on plant health, right? We're trying to get invigoration of plant health. It looks like I got to go really fast. Invigorating plant health for as much net primary productivity as possible to really try to get this system moving forward as fast as possible. So we're doing green manures, we're doing wood chips, and we're then in this year, we're starting to integrate livestock into the system as well. And even within our pastures, we're doing a lot of diversity. So thinking about how different species grow at different times. This is a cool season mix with a lot of legumes. We're also going to be incorporating a lot of warm season grasses. This is a mature oak savanna where we seeded a bunch of oak warm season grasses in the understory. We're also taking out cornfield and putting in warm season grasses, planting prairie strips. And again, moving that needle. We're managing an ecosystem. We're trying to manage an ecosystem to get as much benefits out of as possible, focusing on soil health, but it has to pay higher than corn. So that is our second objective, is that the outcomes, the diversity and complexity that we're doing is try to achieve a system that's easy and replicatable, but is a higher value than corn. Again, Nate Lawrence is on this call and can better speak to some of the research that we're doing. We have baseline soil samples, and we'll be able to represent to you what our outcomes are over the next few years. So come out and join us for some field tours. Feel free to ask any questions with the 8 minutes we got left over, sorry. And yeah, we're available anytime to help answer questions and help with the soil health community.
Thank you so much, Eric. I
Yeah.
appreciate that. And sorry to rush you through. I know these are all topics that we could talk about for hours and hours, days, and probably for the rest of our lives. But this is just the intro to really get us thinking and talking more. So I'm gonna open up the Q&A for Randy and Erik with kind of a combination of a few questions that I saw come through the chat. And I think that one of the guests really kind of wrapped it up well with if all of these 5 badges of soil health are kind of like the gold standard of improving organic matter and generating soil and sequestering carbon, it can be sometimes kind of hard to hit all of those. And Erik, you kind of touched on this, that it's, you know, you do this work over time. So I wonder if there are, if both Randy and Erik can talk about, you know, are there certain tweaks to species that we can make to help better support and lead us into successions that hit this kind of 5 principle badge goal? Or is it really something where we have to address it at a practice or a whole system level to really help achieve that goal?
Well, I'll go first if that's all right, Erik. I think it's a great question, and I get it that like my message in particular is pretty daunting, and especially if you don't have livestock or if you have constraints, as somebody mentioned in the Q&A. And so I just want to make clear, like, I'm not saying people shouldn't be working towards these 5 badges, that they shouldn't be, you know, if they don't have the ability to do all 5, I want to encourage them to work as hard as they can to do the ones that they can. But I think there's an important message and information for society that's trying to reward folks for, say, excuse me, taking carbon out of the atmosphere and putting it in soil and paying them to do that. You know, if we're going to pay people to do that, we better really be sure that we're taking carbon out of the atmosphere and putting it in soil. And so I want to pay people also to hold on to nutrients, you know, which cover crops do. They may not build carbon, but they certainly hold on to nutrients. They slow down the loss of nutrients. So I think that incremental improvements are critical, but I also think that we have to eventually, you know, in the decades coming up, move towards these perennial systems that integrate livestock, et cetera. And so that's what Grassland 2.0 is all about, is trying to think about, like, what are the impediments to getting there? Because they're real. And it's so wonderful that Savanna Institute, as Erik just laid out, is actually kind of demonstrating what the successional pathways to getting there can be.
Yeah, and I would just add that, you know, I 100% agree. It's incredibly complicated, and I don't know if we're not really trying to say that there's one way of doing anything. And really, I think that's kind of the part of it, is that everything's contextual and everything is based on intentional design, and then management towards that design. And I think there's a number of ways to go about that. And I think largely it's a way of training good TSPs, getting a lot of people on the landscape to help for free or as low cost as possible, to not just walk people through the design process, but also through the management process and the successional process. Because things change, like I mentioned, and we both mentioned, like, no 2 farm is exactly the same. The soil is different, the slopes are different, the climate and the rainfall is different. Species selection based on soil type is of absolute paramount. And that goes back to the design, is really kind of tailoring the system to what the outcomes, the objectives and the outcomes are actually desired for and what is actually needed. But that's incredibly complicated. And it requires a whole community system. It requires a whole support structure. Both financially, but also even just emotionally, but also just technically, because it is so complicated, and the science changes too. You know, as we learn and as we evolve, and discover new methods or new opportunities, or how incredibly important that contextual piece is and the complexity of that contextual piece. There's so much that we're going to learn just over even the next 5-10 years, not even on our site, but across the globe, on actually how to move this needle forward. But without good relationships there between TSPs and community and the farmers, and good help along the way, not just at the beginning and set them up with a badge and say, here's your badge, go operate on the badge. It's following through on what that badge actually did, and if that badge needs to be tweaked and have others added to it. I think that's kind of one of the major barriers, and so much so for sure in agroforestry adoption.
Thanks so much, Erik. We had a couple of questions that were related to kind of focusing on producers and farmers, and is there particular data or messaging that folks find that makes people more receptive to moving the needle on some of these things that you both were just touching on? I know Grassland 2.0 and both the work that Savanna Institute is doing is really kind of focused on interacting with farmers and producers and figuring out what's possible to help really integrate this work.
Yeah, it's really a great question, and I'll say that the Grassland 2.0 experience has been like Erik mentioned in his talk, that it's critical that it makes sense economically. We can't ask farmers to do things that don't make sense economically, although I guess we do that to a large degree now, and backstop it with subsidies. But anyway, let me not go down that road. What's one of the things that's been a real eye-opener for us and for farmers that we've talked to is the economic advantages of grazing dairy heifers, replacement heifers, that are really just a net cost for a dairy, and with no income generated for that year or two that they're being reared. And so even some big CAFOs that we're working with up in the Marathon County part of Wisconsin, in that learning hub, as we call it, are coming around to the idea that it's at least half as costly to raise their heifers on grassland, and sometimes more, sometimes even less than that. And not only is it cheaper by about half, when the animals come back into the lactating herd, they have fewer health problems, they're more productive, the cull rates are lower, et cetera, et cetera. So there's all these benefits once they enter the lactating herd. And so that's been, we think, a real avenue for where even, producers that you might think are sort of so dug into a particular system that they'll never change are coming around to the idea of more grass. And obviously it's more complicated than that, because then you have to talk about where's the land, who has the land, et cetera.
I don't know if you want me to respond, Katie, but if you can actually repeat the question, unless you wanted to move on to the next one. I know we're at one, so.
Sure. Yeah, I think that you kind of answered that with the technical service program aspect of the ways that we can talk with farmers and producers and landholders to help provide options and then help them through the whole process and not just the beginning part of it.
Yeah,
there was.
Go ahead.
Go ahead.
No, go for it.
There was one question. Sorry, I lost my notes here. There was one question about how applicable silvopasture systems are to arid or semi-arid places, especially in the Southwest. And I want to broaden that question a little bit. And are these, when we're talking about these different systems, are these things that are only applicable here in the Midwest, or is it something that can be shared and different things developed for different areas of the U.S.?
Yeah, I would jump in here real quick and just say absolutely. I mean, silvopasture is just a conceptual idea. It's not a practice or a strategy or prescription, so to speak, that needs to be repeated with the same species, and with the same livestock species even. Again, going back to the design and the contextual piece, these ideas and these concepts are applicable within, I think, every region. That makes sense, and really within a management framework. So if there's a need for shade, if there's a need for kind of helping to maintain soil moisture to keep grasses from going in lag period too fast, or depending on what the grass species are in the understory, that I think that's a big question too. you know, silvopasture comes from all over the world, from temperate rainforest to to the dehesas in Spain, which are an arid landscape. You know, I would say that there's some examples of, there's great examples of silvopasture all over the Southwest, but, you know, a lot of the Southwest is rangeland management. So there's not, with silvopasture, it's not just grazing under trees, it's grazing for the intentional outcome of the tree being its at maximum plant health for an objective outcome, whether it's habitat, wildlife, shade, whatever, but you're actually intending for that tree to be a part of the system, not just it's there, graze a cow under it. That's where we lead into issues with silvopasture. But certainly, I mean, these systems are replicatable all over the world. It just, you know, don't take it as a prescription, so to speak, but take the ideology and kind of cater it to the specific context and the specific manager. That's itself. I don't know if you have any thoughts on silvopasture, Andy.
Well, I would just add that I think maybe what you're saying from an ecological speak is, like I say in my title, like restoring the structure and the function of the ecosystem or the biome that you're in. So much of our agriculture has removed key elements of the structure of an ecosystem, for instance, deep roots. And so we have to restore deep roots to our agricultural systems if we're going to get carbon stabilization out of our agricultural system. So much of our system has removed livestock from grasslands, and you know, we grow all our feed in one part of the continent and truck it all down to where all the animals are in confinement, feed them down there. We just have to move away from that sort of deconstructed ecosystem, if you will, and integrate it back. And I get it that that's hard, especially if you've been down the road of a deconstructed type of system. And so that's part of what we're trying to do in Grassland 2.0. It's like identify what are those barriers into reconstructing the system eventually and getting it back to fully function. And that can happen anywhere. Savannas, forests, grasslands, deserts.
Thank you so much, Randy, for kind of ending our conversation today on that kind of hopeful note that this work is possible everywhere and it's very localized, and we get the opportunity, the power, and the hard work of working with others to make those decisions to really boost soil health where we are. So I want to wrap up by really thanking Erik and Randy for joining us today and sharing their expertise and giving us some good pathways on the ways that we can think about the ways to integrate practices if we steward farmland or if we work with folks that do that stewardship and really hard and good work. So as a reminder to everyone, if your question wasn't answered today, please feel free to reach out to Savanna Institute or our partners, and be sure to follow and connect with Grasslands 2.0 and the Savanna Institute, and come check out what's happening on the North Farm or any of our demonstration farms in here in Illinois. So thanks again to the EPA, Liberty Prairie Foundation, and Delta Institute for supporting this webinar series, and keep an eye out for our next ones coming up over the rest of the year. So have a wonderful day, everyone.
Take care.